Hello, everybody. We have exam one coming up next week. So I want to go ahead and give you a little bit of a primer and a guide to how exams work here in our astronomy class. So this is your guide to astronomy exams, how they work and what to expect. Let's just go ahead and start with some of the general information, sort of the policies of how things work. And this is going to apply for all of our during the semester exams, exams 1 through 3. Each of these exams will be 55 questions long. However, I give you a little bit of mercy with being able to miss up to 5 questions without it affecting your grade, which effectively means that I grade the exams out of 50. So 50 correct responses earns you a 100%. Every question past 50 is plus 2% extra credit added to the exam. So if you get 51 questions right, you got 102. What happens if you say get 45 questions right? Well, I'm grading out of 50. 45 divided by 50 times 100, you would get a 90%. If you get 40 questions right, that's an 80%. All right, so that's how the exams are generally designed, a number of questions and how they're graded. Once you start the exam, you're going to be given a full 90 minutes to complete the exam. The exams are designed to be completed in about 35 minutes to 45 minutes for the average student. As I've moved things online, that's gone up to most people finishing within about 50 to 60 minutes or so, which gives you a good bit of wiggle room. I designed the 90-minute window to give you a nice wide time to actually think about, contemplate, and respond to the questions while also reducing that timer stress that hits so many people. That we have exam pressures and exam stress. It's just a more intense environment. And one of the factors that can affect it the most is feeling like you're rushed. So I expanded out the window. So hopefully that your stress levels from that timer over your head goes down. But I couldn't just make it all day long because it needs to end at some point. I need to assess you. I can just give you all day long to do it. 90 minutes seems like the right amount of time. All right, so you have 90 minutes to complete the exam once you start it. Exams are open book and open notes. They are not, however, open friends. I have a bunch of different unique versions of the exams to make sure that you're not taking the same exam as your friends. Therefore, by trying to work with friends, you're probably making things more difficult and going to end up worse off than if you just worked alone and studied for the exam and, engaged in trying to learn the material and better yourself and empower yourself with a little bit of critical thinking and astronomical knowledge. Okay, so there's my spiel about exams are open book and open notes. I've designed my exams knowing that they're going to be open book and open note as well. This means you do not have to download Lockdown Browser or any respondus monitoring software. I do not use them for my exams. For every exam, just like with the quizzes, you're going to get 2 attempts. So the same 2 attempt policy is in place. For all exams, the first attempt is on a Monday, the second attempt is on a Thursday. Our exam one is happening next week. So on Monday, the 1st of March, you will have the opportunity to take exam one. And then I will review the results. And on Tuesday, I will release more information, targeted feedback based on the performance. Where are the most missed concepts? Where do you need to focus your studying? Clearing up some of the just things that were commonly missed. And then you can also use that discussion to ask me questions, and we can iterate back and forth until you feel like you are more prepared for the second attempt. So we do have that review that's going to happen between that, and you will have the choice to use the second attempt or not use it, just like with the quizzes. If you choose to not use the second attempt, your first attempt is your grade for the exam. If you use the second attempt, your exam one grade will be the average of your 2 attempts. And based on last semester, people that used the second attempt to improve their grade went up by about 5 to 10 points on the exam on average. So it is a big benefit. And that's between attempts, 5 to 10 points. So remember, I'm going to average those together. So that comes to a grade improvement of about 2.5 points to about 5 points. So a quarter to half a letter grade improvement by using the second attempt on average. And very few cases of exam scores going down. All right. And just to be super clear about this, you must use the first attempt. Excuse me a second. And finally, when are the exams available to you? Exams are available to you from 9 a.m. until 9 p.m. Eastern Time on attempt days. So you have the same attempt window that you do for the quizzes. And you might have been wondering, why do I close it at 9 p.m. and not just let it go out to midnight? Well, with things like quizzes and exams, it's very important for me to be able to help you out if anything goes astray, like your internet connection goes bad, something comes up, something weird is happening, something's not working right, whatever. You probably want me able to help. And it's really, really hard for me to stay glued to my computer all the way until 11:59 p.m. on attempt days. So I made the window a nice 12-hour windows from 9 a.m. to 9 p.m. Just please keep that in mind, which means if you want to use the full 90-minute attempt, you must start by 7:30 p.m. Eastern Time. And that'll give you all the way until 9 p.m. to complete the exam. Next, I want to talk to you about exam design. And exams in general are broken into two different parts, the general questions part, and then a series of themed question sets, where a themed question set is I'll have some sort of a theme, and then there'll be several questions about that theme. This is my way to pick important concepts, the ones I want to reinforce most in this class, and have you engage with them on a more full format. I want you to actually, I want to probe your knowledge to see how well you mastered some of these bigger concepts in class. All right, so the best way for me to actually give you an example and describe how these themed question sets are is to just go ahead and tell you what the themed question sets are for exam one. So after you go through the first part of the exam, about 40-ish questions or so, then you'll hit the themed questions. One of the themed questions is working with Newtonian gravity. So if I change the mass, if I have some sort of standard scenario and then I change the masses, how does gravity change? If I change the distance between those masses, how does gravity change? If I change the masses and the distances between those masses, how does gravity change? So working with Newtonian gravity. So several questions about working with Newton's gravitational equation. Another one is understanding the phases of the moon. I give you an orbital diagram and I show you where the moon is in relation to the Earth and the sun as it's moving around, and you tell me what the phase of the moon is. You can be able to, I'll also see if you know the difference between synodic and sidereal month. If you know if we're to wait a week, where would the moon be and what would the phase be? Can you recognize the phase of the moon? Can you differentiate between waxing and waning? So lots of questions about the phases of the moon. And then the final one is working with an imaginary planetary system, where I'm going to make up an imaginary planetary system that is a star that's identical to the sun, which is key because that's going to allow all of Kepler's laws to be in effect. And then I'll give you planetary data about the planets in orbit around this star. Things like their axial tilt, their orbital period, their semi-major axis, their eccentricity, a whole host of different planetary properties I can give you. And then you'll have to take that information and answer some key course concepts. One of the big ones is seasons. Can you understand the seasons that are happening for the planets in this imaginary system based on the planetary data that I give you? And again, can you identify what season a planet is by looking at what the orbit, its orbit around the sun or around the star? Then, of course, using Kepler's third law. If I give you the semi-major axis, can you tell me the orbital period? If I give you the orbital period, can you tell me the semi-major axis? And then a couple of other related questions. So as you can see, there'll be several questions in each one of these themed question sets, but they're all on some bigger theme. These questions are typically a little bit more in depth and therefore perceived to be a little bit more difficult, but you know what they are now. So you can prepare, and yes, I will release this information in a different format as well in case you already tuned out and you're not paying attention to anything that I'm saying. So what about question design? And I'm very, very, very deliberate in how I create questions. Just in general, most questions are multiple choice. However, I occasionally will use multiple select or matching type questions, more often than multiple select, which means that you'll see some sort of indicator, so probably some bold colored text that says choose all that apply. That's your indicator. That's a multiple select, and you can select more than one answer. But in general, most of the questions are multiple choice. And then I design my questions and how many of each type of question there are very, very deliberately. to create what I think are fair exams that test the breadth and depth of your knowledge over the material. So I create three levels of questions. Level one questions, about 70% of all the questions on the exam, are simply, do you know the vocabulary or can you recognize the concept that we've talked about in class? So, can you basically identify the correct concept? Can you identify a description of a concept? Do you know what the vocabulary words mean? So these are pretty simple and direct, and they're just making sure that we all have some sort of common level of mastery over the language that we use and the terms and the concepts that we've been talking about. Level two question starts to dig in a little bit. This is about 25% of the questions on the exam. It varies from exam to exam. And this is, can you apply a concept as we've done, say, on a quiz? That's the best way to gauge the difficulty level, is that exam questions are very similar to quiz questions in difficulty. Or can you do a concept, work with a concept as we have on homework and EE, and engagement exercises? Now, I want to give you a little bit of information about that part as we've done on a quiz. I work very hard on coming up with what I think are valuable questions that reinforce the course concepts and get you thinking about them, which means that several of those quiz questions are going that you had on quiz 1 and 2 for exam 1 will reappear. So you will have probably a different version, maybe different numbers. It's a mathematical analysis type 1, but the same basic question. That's, if you got it right, I want to make sure you still know how to get it, or you can get the correct answer multiple times. If you missed it, I want to give you the opportunity to show me that you've mastered that skill. But level two questions are applying a concept, lots of times mathematical analysis. Or perhaps, hey, it's the northern hemisphere summer solstice. So how does the axial tilt, the 23.5 degrees, whenever we're in the summer? What is it? What are the two things that actually create the warmer temperatures of summer? Well, you have longer days and more concentrated sunlight. So applying some concept that we have. And then finally, we have level three type questions. Level three questions are only about 5% of the exam. They're rare, but that rarity is matched by an increased amount of difficulty. And these are questions that extend course concepts beyond what we've worked with in class thus far. Because if you truly know a concept and understand it, you should be able to apply it in a new novel situation. This is the deepest level of knowledge. This is a level of mastery I hope all of you achieve in whatever it is that you're passionate about in life and want to focus your intellectual endeavors on. And I put 5% of my questions so you can practice that with astronomy. So, extended course concept. Another good way to do a level three question is, can you combine and integrate knowledge? So, can I take two concepts and bring them together? So, in using those concepts in concert, can you answer some question about astronomy? So, those are level three questions. And you can see the breakdown right there. It all adds up to 100%. So now you know how my exams are very deliberately designed. And then just a little bit of extra information. If you've not looked at the must knows for the exam yet, please go look at the must knows for the exam, because they are a study guide I made for the exam. And then I designed the exam based on the study guide I created for it, which means that it's a very valuable tool for you to look at, study, and digest. Every question on the exam will have a bullet point or a sub bullet point somewhere on the must knows related to that question. Now, that's a lot of information that's in there, and there's only a 55 question exam, so you're going to be not engaging with every possible thing that you could. So every bullet point on the must knows doesn't become a question, but every question does have a bullet point somewhere in the must knows. So this is my way of saying you should get a general understanding of the must knows. And finally, I have many, many unique versions of the exams. And this is so I can have open book, open note online exams that don't rely on Respondus or lockdown browser software. And just to give you an example of what I mean by many, that is italicized there. For exam 1, there are 8.86 times 10 to the 20th unique versions. That's close to 10 to the 21. 10 to the 21 is 1 billion trillion unique versions of the exam. So I can guarantee you're not taking the same exam as your friends. So I use lots of different unique versions of the exams, so be aware of that. That also means that when you take your second attempt, it'll be a different version than your first attempt. Same content, different version. Okay, if you want to go ahead and tune out, you're welcome to, but I'm going to encourage you to stick around because I want to give you some more information about the study guide itself for the exam. So what I've covered so far is just about exams in general. Now I want to tell you how you can engage with the study guide so you can perform as well as you would like to on the exam using my study guide. So hopefully you stuck around. Let's just get into the must knows. So the must knows is a guide that summarizes all the major concepts and terms that we have covered that will be on an exam. It is a very explicit list of the content covered on the exam. So it's even better than exam one covers unit one, parts 1 through 3. This one goes down and gives you bulleted items. Those things could be on the exam. And as I just said, I have designed my exams based on the must knows. I've designed my exams based on the quizzes, based on the homework, based on the engagement exercises, based on my lecture videos, based on my notes. I've worked very hard to make sure everything is integrated and has meaning in this class because it relates to other things that you're doing in this class. Okay, so hopefully you're motivated to actually use the must knows as a study guide. Let me tell you how you can use them. First thing you want to do is go through and identify the terms and concepts that you need to study. These are the blue text things. Just go through them. I often like to write things down. That's my method of studying. Everybody has their own method. Hopefully, you can practice, and by the end of this semester, you'll be a little bit better at studying in general. But I like to go through and look at terms and concepts and write them down. And by writing them down, I then know whether I know them or I don't know them. And I cue you into these by blue text, that bold blue text. And the ones that I do know, yeah, I'm going to probably review those before the exam, but I'm really going to start focusing my study on the ones that I don't yet have mastery of, that I don't yet know. So identify terms and concepts that you need to study. As you go through, you'll see that there's lots of missing details in my must know. Sometimes I delete stuff and I put a blank instead, or I ask open ended questions. Fill out all those details. You can't just read the must knows and that's it. I didn't do the studying for you. You're the one that has to study. That's not something I can do. I can only offer you materials. You have to pick up the mantle and do the studying. So fill out all those missing details. Answer all those open ended questions. If there's a blank, fill out the blanks. If there are example questions in there, you should know how to do them. So don't just memorize the answers because the goal is to understand how to get the right answers, not recognizing a right answer because you've seen that question before. I am really interested in you gaining understanding. I want you to understand how to get the right answer. And I am going to be testing on that. So the example questions that I give you are there so you can contemplate and work on them independently. And then if you still have trouble, I'm giving you plenty of opportunity in the pre-exam Canvas discussion. You can email me. We have the chat app, so you can use GroupMe or the Discord server or whatever. You have plenty of chances to engage with that stuff, work on them, and then if you're really, really stuck, ask me about them. So if there are example questions, you should work through the examples and know how to get the right answers, not just what the right answers are, how to get them. And then finally, I suggest that after you've done a good bit of studying, you start working on building a 1 to 2 page study sheet for yourself. Get a sheet of paper and just write down the stuff that you're having the most trouble with, the things that you most want to remember. So you have this little personal study guide that's pretty short, just the front and back of a piece of paper, or maybe just the front. And then that way, when you're taking the exam, and all of a sudden you hit a question, you're like, oh no, I don't remember how to do this. I don't remember how to do this. You feel that pressure of the clock over your head, but you have a study guide that you made that you know, since you created it, where you have that information. And since you created it, you probably built a mental map between that and my must knows guides and my notes. So you actually have information on how you can go and get that information because it is an open note exam. So creating a 1 to 2 page study guide is a great study habit. By creating it, you are actually doing the studying. Apparently, I copied and pasted that slide. Okay, This is where people have the most fear and trepidation and anxiety, the mathematical analysis questions. Hopefully I can alleviate a little bit of that. I'm not going to ask you the same question over and over and over and over and over and over again. So with, let's say, angular size and distance, you either know it or you don't. So if I ask you 5 questions about it, that's saying that I think this is 5 times more important than every other concept, which that's an unfair weighting in my mind. So I'm probably gonna ask you 1 question about it. You either know it or you don't know it. Show me that you know it. So don't expect the entire exam to just be crunching through, solve 5 of these angular size and distance, now solve 15 gravity questions. No, for every mathematical concept that I want you to be able to work through, there'll be 1 question. Now, notice that with gravity, I could change the masses and not the distance. I could change the distance, but not the masses, and I could change the masses and the distance. Maybe I could ask up to 3 questions about that. All right, so mathematical analysis questions, yes, they are on the exam, but it's not the majority of the exam. Hopefully that backs off a little bit of the anxiety if you're feeling anxiety over the mathematical analysis. Also, let me just be a little explicit about at least exam 1 mathematical analysis questions. Be able to use Kepler's third law. P squared equals A cubed. Period is in years. A is the semi-major axis measured in the distance unit of astronomical units, or AU. And the way that you have to do it is I'll give you P and you solve for A. So I give you the period in years, you tell me the semi-major axis in AU. I give you the semi-major axis A and AU, and you solve for the period P in years. Angular size and distance are inversely proportional to one another. If I give you the angular size of something when viewed from some standard distance, Earth, for example, and the moon has an angular size of 30 arc minutes when viewed from Earth, you should be able to determine the angular size if that object were to appear at a different distance. If it was 2 times closer, it'd look 2 times bigger. The moon would be a full degree in the sky. If it was 5 times further away, it would look 5 times smaller. So it'd be 1/5 the size. So it'd be about 6 arc minutes in size. So the key with all of these sort of thinking proportional rather than just plugging numbers into the equation is to figure out the multiplicative change. So in this case, to the distance, or the multiplicative change to the angular size. So what am I multiplying it by to change it? So ask yourself, is the distance that's asked about, is it 2 times the standard, 16 times the standard, 1/5 the standard, and then apply the thinking proportionally. So inversely proportional, if it's 16 times the distance, then the angular size will become 1/16th, the multiplicative inverse. If it's 5 times, or it's 1/5 the standard, so the distance has decreased to be 1/5 what it was, you're 5 times closer, then the angular size would increase by the multiplicative inverse of 1/5, or it'd be 5 times bigger. Know that parallax and distance are inversely proportional. I'm not really going to have you work too many problems with this one, so don't expect too much mathematical analysis like the angular size and distance. I just want to put this on there so that you are aware that it's the same as angular size and distance, and that you can recognize the concept. So it's more important for you to recognize the concept, and maybe like that quiz question, be able to look at various parallaxes and tell me which star is closest to the Earth and which one's farthest away from the Earth. Another big one is working with Newtonian gravity. And this is basically the theme question set of Newtonian gravity. Here's the equation. I suggest that you become familiar with my template and how to use it. I have the video in week 5 where we're working with the template that I have, or come to the exam review sessions that are this week's Live with Dr. Lindsay's if you have questions about that. If you can learn how to use the template, these questions become much, much easier. But working with gravity, so given a change from one arrangement of the masses and distances to some new one, so we'll have a standard and then we're going to change that standard, you should be able to tell me how gravity would change if only the masses change, how the gravity would change if only the distance between the masses changes, but the masses themselves don't change. And if I change everything, if I change the masses and the distances, and you should be able to tell me how gravity compares in the new scenario compared to the old one. Did it get stronger? Did it get weaker? How many times stronger? How many times weaker? So again, I really emphasize making sure that you know how to use that template. It's really a cleaner way for you to start engaging with, and a controlled way for you to engage with a more complicated thinking proportionally, where we have directly proportional to the product of the masses while we're simultaneously inversely proportional to the distance squared in inverse square law. Surface gravity, orbital velocity, and escape velocity. These are all mathematical things that we've talked about, but I'm not going to really have you engaging with the equations so much. I want you to understand how things change, thinking proportionally without actually necessarily needing to crank out the numbers. So, understand how they change as the mass of an object and the distance from it changes. So, if I increase the distance that, say, the Earth has some orbital velocity, and then I make the Earth move 3 times farther away, so now it's farther away, would the orbital velocity be larger or smaller, or would it remain the same? So, if I change the situation up on something, how would each one of these things change in response? What direction would they move? Maybe not give me the number, but know what direction, if they become stronger, weaker, or stay the same. And that's basically what that bullet point says. And that's my quick guide that I have for you. If you do have any other questions about the exam, make sure to post them in the pre-exam one study guide sort of Canvas discussion that I have. I hope this was helpful to you. I hope you understand our exams. Good luck on exam one. I am here to help you. So please ask me questions if you have them.